So as we get ready to start graphing our cosine function, we've been dealing with sine for the past couple of days. Again, we've got our note card we've been building here with sine starting at 0, and then going up, back to 0, down, back to 0. And our A value, our amplitude, gets changed with that and can change these values, and we multiply them through. Then what we did is we talked about what the angle measures were for sine. These are my typical sine parent points, my period being 2 pi, and that never does change. But if I do get a B value, okay, a value in front of my theta, in front of my angle measure, we multiply by 1 over that value to change these. And we've talked about that a bit. Today, as we get into cosine, a lot of this is going to be the same. My parent points are going to be the same. Okay, these are not going to change. However, once we get to the cosine side of our card, my base y values are going to change. And those are based on... This will be interesting later, but this is how life goes. So we can let YouTube Nation figure it out too. Unfortunately, there will always be students that we have here that don't have here for one reason or another. That's how it goes. But back to cosine here. Cosine starts at 1. That's the biggest change with these. And that's how I tell people, that's how you tell the difference on how to tell them apart. Sine is typically, when you're kind of looking at a picture, it tends to go up, and then it goes down, and then it comes back up. It's kind of like a sideways S in some ways. We got a hill, we got a valley. Cosine is a little different. Since it starts up at the top, it kind of goes up, and then it comes down, and then it goes back up. It looks more like a big U rather than the curves. So there's a couple of ways I can start to tell what the difference is going to be between those. And similar to when we did our sine values before, I'm just going to move this out of the way for a second here. They don't just come from Harty making something up. They do come, even though I forgot 0, 0 in here again, they do come from the same values, except that's 1. Silly man. It's those same values that create my period being from 0 to 2 pi. And like we said before, it makes kind of this U or V shape, starting at the max at 1, and then coming down to 0 at pi over 2, negative 1 at pi, and then back to 0, and then back to the maximum. So there's definitely a change in look between those. And that's one of the things that we're going to work on. Now, everything else is going to look eerily similar? No. Well, similar, yeah, or familiar. So I look in here, and just kind of as a review for us here, my amplitude, my A value, is the distance from the midline to the highest peak or lowest valley. You're like, yep, that's no different than it was before. And our A value, when we have them, is going to be in front of my cosine, in front of my sine value. And that's going to tell me how much my graph is going to stretch up or down, or it might shrink if it's fractional. The other part of this is my period, okay? The time it takes to complete one pattern. And with these, again, it's going to be 2 pi. Now, even though we'll mention this down below, the value within that causes this to be a little bit different, okay, is going to be my B value. Now, my B value is not my period. My period is 2 pi divided by B, with B being the number of cycles that happen in one period, that happen in 2 pi. Hence the 2 pi divided by b. So, I'm hoping once we start to move a little further down that you're like, wait a minute, this basically, all of this looks the same as sine did. And it's true. Because as I move down a little bit more, again, my amplitude, still in front of cosine, the period is the same here. So, all of that information is the same as sine. I don't have anything new I have to remember. If I've been getting anywhere with the sine functions, there's very little extra I'm going to have to take into consideration. And that's going to be true all the way through with these. So for instance, what is the period of each cosine function? Okay. I find my b value in front. The formula is 2 pi divided by b. Now, if I'm going to go to my calculator to help me on this, I would not put the pi part in. It would just be the 2 divided by 1/4. If I'm going to do it manually, if I'm going to use my brain power here, dividing by a fraction is the same as multiplying by its reciprocal, multiplying by its flip. So 2 pi times 4 would be 8 pi, and I'd find my period. And really, the only reason that's a little trickier, it takes a little longer, why? Because, well, it's a fraction. Here, when my b value is a whole number, 2 pi divided by 2. 2 divided by 2 is 1, or just pi. So finding the period shouldn't be too rough for us, okay? I would hope not, especially since we have access to a calculator if we need it. But for the rest, as we kind of flip over and keep taking a peek at this, it's those same pieces that we were using for our sine graph before. Okay, what's the amplitude? What's the a value? Whatever the value is in front. But be careful. Amplitude is always positive, just like we said before with sine. So just because my a value is negative, that would change the way my graph looks, but it does not change the fact that my amplitude, being a distance, is still a positive number. Doesn't change, doesn't change, doesn't change. So when we do any of these, and we're just going to do b in this next section because I want you to start seeing how this works. Find the amplitude and period. Okay, amplitude, I see a number in front. I see this -1. But just because my a value is negative doesn't mean my amplitude is. Okay, this can change the way my graph looks, but the distance doesn't. And then my period is 2 pi over b. And if you are going to go to the calculator with this, you've got to have the parentheses on your 1/3. Okay, work on that. So I start looking and I'm like, okay, let's see. Divide by 1/3, same as multiplying by the reciprocal, or the flip. And I get my answer. But again, the only time I have to flip it is if it's a fraction. If it's a whole number, just divide it and be done. Just like we did on number 1 on the front. So then it says write a cosine function. Okay, but instead of giving me a and b, they're going to give me the amplitude and the period. So when I'm looking at this, when I'm going to write a function, what I've got to remind myself is that b value isn't the period. The b value is the number of cycles. So when I go to write this, I'm like, okay, y equals 5 cosine. I got to figure this part out. So to do that, I'm going to take my period equation, which is 2 pi over b, and I'm going to set that equal, and this is kind of tricky. This is 1/2 pi, not 1 over 2 pi. I wish I'd have written it this way so you could have seen that better. So it actually is this value. And whenever we have something that's a proportion, and that's what this is, I got one fraction on each side. There's no pluses or minuses anywhere. We're just going to cross multiply. And since I'm trying to solve for b, whatever's with b is what I'm going to divide by. And my b value is what I'm going to plug in to create my equation, to create my cosine function. And since that's a little different of a concept, I want to do the second one here too, just to kind of let us see how this goes. The amplitude should always be the easy part for us. But then the period, again, little side work in order here. 2 pi over b equals 3 pi, and I guess to make it a fraction, I'll put it over 1. Not a bad idea, since I'm looking at this like a proportion. I cross multiply. And again, I look on the side that has the b, and anything that is not b I need to divide by. And yes, I can get fractions for b. That can happen. And I get my equation. And we're set with that. So you're like, okay, this really hasn't changed that much from sine. And that would be true. The only real difference we're going to see between the sine and the cosine that we've been doing is when we get to this step, when we get to the graphing. The steps are going to be the same. It's just going to be where the value is coming from. So if you were to do a side-by-side with when we did this for sine, this stuff is going to be the same except for these values right here. And we're going to chat about those with our cards here. So, first things first, find the period, create a scale for the x-axis. So, first thing I'm going to do, I find my b value. My b value is 2. So once I do that, 2 pi over b. Just cancel and just give me pi. And that is my period. And when we were even doing the sine graphs before, we said, okay, we have got 5 points we're going to graph. We're going to start with 0. And whatever my period is the last one I'm going to have. My job is to figure out the ones in the middle. And we've talked about a couple of ways that you can do that. And I'm going to do that same chat here on this first one here. So when I'm trying to find these values, I'm going to do a little side work here. One way I can do it is to make myself a chart. So what I normally would do here is I would take my parent points okay, that's normally the points that I would use along here. But now what I'm going to do is I'm going to take my b value, which is 2, and I'm going to multiply these by the reciprocal of that value, or the flip. If I take 2, or 2 over 1, and I flip it, it's 1 over 2. So basically what I'm going to be doing is I'm going to be multiplying each of these values by 1 over 2. And some of you are going to look at this differently. Some of you are more visual. You're going to want to look at a chart like this. Others of you might even be able to just keep your card out and just go, okay, it's times 1 over 2, times 1 over 2, and create your values from it. Everybody's different. So here, 0 times a half is 0. Well, I already knew that. I had that one in here. Here, if I multiply across, pi times 1 is pi. 2 times 2 is 4. That's my first line. Pi times 1 is pi. 1 times 2 would be 2. Pi over 2. 3 pi times 1, 3 pi. 2 times 2, 4. 3 pi over 4. And 2 pi times 1 would be 2 pi over 2, which is pi. And that's kind of my double check to make sure that this is working. Yeah. What you're going to do, good question. So how's the pi going to come in if I'm doing this stuff in the calculator? Actually, let me do that right now so we can take a peek. Our other way of tackling this would be to kind of start doing what I like to call halvesies. Okay? And here's how halvesies would work. I would look at this and I'd say, okay, this is going to be 0. Since I don't see a number in front of pi, this would be 1. So what my goal is going to be is to keep finding values in the middle and kind of keep cutting them out. But I'm not going to use the pi on my calculator as I'm doing this. So if I'm going to do halvesies, most of the time I can do these in my head. You're like, okay, well, what do you mean? What's right in the middle of 0 and 1? A half, or 0.5. So notice, if I put the pi up top, which is where it would go with these, I'd end up with pi over 2. Now, maybe you're not sure what's in the middle of 0 and 1/2, though. And here's what I mean when I say we can do this in the calculator, we're just not going to include pi. You're like, I don't know what's in the middle of 0 and 1/2. Okay, well, let's do 0 plus, whoa. Okay, 0 plus 1/2. Okay, but I want to know what's in the middle of it. So I'm going to divide it by 2. Math, enter. 1/4. Or if I come to this side, I don't know what's in between 1/2 and 1. Okay. 1/2 plus 1, divide by 2. Math, enter. 3/4. And if I did it that way using the calculator, when I'm doing my points, all I got to remember now is the pi goes back on top. Pi over 4. Pi over 2. 3 pi over 4. 1 pi. So the chart can do it, or doing halvesies can do it. So you just have got to kind of play with both maybe and see which one that you want to try. And so then once I have that, my last step to this, now my amplitude, okay, here is 3. But my A value is -3. So how does that change things? Well, here's my normal cosine points. So here, I take whatever my value is at each of these. So my first point normally is at 1. Multiply it by the A value, the -3. So 1 times -3. My first point's at -3. Okay, my second point, 0 times -3 is 0. My third point, because again I'm just moving my way across the lines, is -1. -1 times -3 is +3. Fourth line, 0 times negative 3 is 0. And finally, my last point here, 1 times negative 3 is negative 3. So this actually ends up being, because of the negative a value, a flip of what I'm used to seeing. Looks like a hill now instead of a valley. But again, I want to look at several of these with you. I've kind of learned my lesson as far as making sure that we're chatting these up the first day instead of kind of waiting. Because sometimes just seeing one of something really isn't enough to get me going too far. So what I'm going to do to try and help, I'm avoiding the book today. You're like, woo! So keep this close. We're going to refer back to it. But what I'm going to do is we're going to do a couple of things on this worksheet to kind of get you thinking a little bit. So I'm going to flip this over. We're going to take a look at the worksheet. And we're just going to do some different things in each of the parts. I'm going to do some in each of the parts with you today. So I get here and it says, okay, find the period and amplitude of the cosine section. So here's what our main focus is going to be right now. Find the period, find the amplitude. Now the amplitude should be the easy part. So let's do that first on number 2. The amplitude is just finding the max or the min. So I look. Looks like the maximum is up here about 4. Or if I look at the minimum looks like it's down about negative 4. But amplitude is always positive. So my amplitude is 4. Okay, that wasn't so bad. Okay, you can handle that part. But what about the period? Okay, now I've got to keep in mind, period is 2 pi divided by b. One cycle starts at 0 and ends at 2 pi. So my thing to figure out is how many cycles occur from the start to the finish. And I go, okay, now remember, cosine starts at 1. Or in this case 4, because my amplitude was a little bit bigger. So I go, okay, so I start here, I go 0 to the bottom, 0 to the top. Okay, so there's one cycle. And I start over again. 0 to the bottom, 0 to the top. 2 cycles. So if I have 2 cycles, my period is 2 pi over b. Okay, number of cycles is my b. The 2's cancel. My period is pi. So that's how I would do these. I'm always looking between 0 and 2 pi to see how many cycles are going to occur in there. I'm not worried about determining the values of theta for all of these. If we find amplitude and period, that's a good start, okay? Because then when we get to the graphs here in a minute, it's going to be a little bit easier for us to deal with. So speaking of that, we're going to be taking a look at number 7 and number 9 here. So I get here, I'm like, okay, sketch the graph for one period. All right. So I notice my a value is 2. So we'll be going as high as 2, as low as negative 2. And I see my b value is 3. Okay, whatever's in front of the x, theta, whatever happens to be there is going to be my b value. So my period is 2 pi over b. And if I try to reduce 2 over 3, I can't. I hit math, enter, enter, still comes back as 2 over 3. So 2 pi over 3 is my last value. Now I got to figure out the stuff in the middle. And again, for this one, I'll show both ranges of, halvesies, or if we're going to actually use our chart. So here's how I'm going to kind of do this. I'm going to go, okay. So let's see. I'm not going to put in my first part of the chart this time. I'm just going to use my little card here. And I'm going to go, okay, what am I going to be multiplying by? Well, if my b value is 3, we multiply by the flip of that. We multiply by the reciprocal. We multiply by 1/3. So I look and I go, okay, if I want to do the times 1/3 thing, I can. That's my call, whatever I need. I'm in control. And so I look and I go, okay, 0 times 1/3, 0. Well, I already knew that. Pi times 1 would be pi. 2 times 3 is 6. Pi times 1 is pi. 1 times 3 is 3. 3 pi times 1 is 3 pi. 2 times 3 is 6. But then I stop and I think for a minute. I'm like, well, wait a minute. 3 over 6, if I put that in the calculator and hit math, enter, I get a half. So pi over 2. And then 2 pi times 1 is 2 pi over 3. I get the same one at the end. That's good news because it means I'm probably doing things right. And I'm going to put my other values in here. Now again, if halvesies was your preference from before, you were like, I kind of like this idea of having the calculator to be able to help me on some things. If I was going to go halvesies, okay, reminder, so we're kind of forgetting that these three are here right now. We take the values numeric, we don't use the pi. So I take my endpoints, 0 plus 2/3, and then I want to find the middle. So I divide it by 2, math, enter. 1 over 3, pi over 3, because again I got to put the pi back. And then, well, what's in between 0 and 1/3? Because that's going to give me this, okay? 0 plus, whoops, I almost forgot my parentheses. That would have been bad. Divide that by 2. Because again, I'm halvesies. I'm looking for the middle. Math, enter. 1/6, pi over 6. And then I'd have 1 left at that point. This one would still be missing. So I'd have 1 over 3 and 2 over 3. 1 over 3 plus 2 over 3. Whoa. Divided by 2. Math, enter. 1/2 pi over 2. I've got to remember to put the pi back in, though, if I'm going to do halvesies. That's the one thing that makes me hesitate with some of you on that. And so once I have that, my a value is 2. Whoops, not signed, though, Harty. That would not be helpful. So I'm just going to take each of my values. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. 0 times 2 is 0. And 1 times 2 is 2. And again, we're trying to get a curve here. That's a more typical cosine graph. It looks like that. And that's really all we're doing on these. The biggest thing for most of you is just going to be picking which way you're going to get your angle measures. And so when we get to this last one on the front here, number 9, okay, we're going to rewrite this first so we don't have any confusion. If there's a negative front, it's like it's a -1. And when you see a fraction, theta over 3, it doesn't mean my b value is 3. It means that's a fraction that's there. So this would be 1/3 theta. So when I start trying to figure out what this is going to look like, I know since my a value is -1, it's going to go as high as 1, as low as -1. And when I'm looking at my b value is 1/3. So I'm like, So my period is 2 pi over b, and dividing by 1/3 is the same as multiplying by 3. So 6 pi is going to be my end value. So this time, I'll do both again, the chart and halvesies, but I'm going to do halvesies first this time. Because this time, I'm sitting there going, oh, I can do halvesies. What's in the middle of 0 and 6? 3. So I can get that one pretty easy. Now, between 0 and 3, maybe easy, maybe not. So I'm like, okay, let's see here. So 0 plus 3 divided by 2. Enter. 3 over 2. So the pi goes on top with my 3 over 2. Then I got one more. I've got what's between 3 and 6. Okay. 3 plus 6. What's in the middle? Enter. 9 over 2. 9 pi over 2. Okay, I've got my values. If that doesn't click for you, and for some of you that won't, this is the one. I'm going to kind of section this off so I can actually get a chart in here. I would, again, pull this up and say, okay, divide by 1/3, same as multiply by 3 over 1. And so I look and I go 0 times 3. Actually, I'll put in my 3 over 1s. Some of you may not want to write it out every time. You may just want to write it out once so you can see. I mean, that's, again, up to you. 0. 3 times pi is 3 pi. 2 times 1 is 2. There's my 3 pi over 2. 3 times pi is 3 pi. 1 times 1 is 1. And I start to see this come together. 3 times 3 is 9 pi. 2 times 1 is 2. There's my 9 pi over 2. And 2 times 3 is 6 pi over 1 is 6 pi. They both get me to the same spot. And so the only thing I've got left now to do is to go through and multiply my cosine values by -1. So -1 times 1 would be -1. 0 times -1 would be 0. -1 times -1 would be +1. 0 times -1 is 0. 1 times -1 is -1. I get my graph. Again, it gets easier as you practice a few of them. And we're going to spend a couple of days kind of doing some of these as well. Let me make sure there's not something on the back that I think is going to be troublesome. Because if it is, I want to make sure we touch on that too. But this is going to be like anything else. Kind of pick something. Ooh, that could be kind of interesting. Let's take a peek at number 15 here, and then we'll call it good for now. Because 10 through 13 is kind of like what we were doing on the note sheet before. Write an equation of a cosine function for each graph. Okay. I need to know my amplitude. I see that right away. So I know this part. But now, I need B. So remember, start at 0, end at 2. 2 pi, excuse me. And how many cycles, how many times does the pattern complete within there? So I'm like, all right, let's see. 1, 2. B value is 2. Not hard, just have to think about it for a minute. Because we're not looking for the period, we're just looking for B. We'll be looking at more of this tomorrow. Kind of cleaning up some things, stuff like that. We'll be looking at a quiz preview after that. Again, kind of going back over some of the same stuff. And that quiz will be coming soon. But get some practice in, play around, figure out which way you like to plot your points best, and let me know if there's any questions.